Hello, my name is Matt Max. Don't get me wrong, the Prusa Mendel greatly simplified the Mendel design and helped popularizing 3D printing at home by a lot. But it has some flaws that, if you put them together, makes you wonder why the Prusa is still the de facto standard for self-built 3D printing at home. Especially when there are better alternatives that cost basically the same and are not more difficult to build. So without further ado, here are the top 5 reasons why the Prusa Mendel, unfortunately, sucks. Reason number 5. X-axis wobble. If you want to join two pieces of material together, you can achieve that in different ways. You can glue, you can weld, you can screw. Now, what the Prusa Mendel does, it uses all those nuts. Now, the problem with that is that it's not really stable. Everywhere you do this, all your threaded rods can move around a little bit. Basically, all those parts are like a little hinge. It's not a really stable construct at all. If I wanted, I could move this by like 4 millimeters back and forth. That's quite significant. And although you have those two big triangles that make up the superstructure of the Prusa Mendel, and although triangles are really, really stable, those triangles only support the z-axis, and with it the x-axis. But what they cannot do is to make sure that your machine won't wobble in this direction. And it will, because your x-axis will start moving back and forth a lot, and it's quite a lot of mass, so your whole machine will start to wobble in the x direction. And not only does this mean that your print is less precise, it also means that you have a lot more wear and tear because your machine is constantly moving. All those threaded rods are constantly moving in the plastic parts and are widening the holes in the plastic parts, and that just results in more maintenance for you. Reason number 4. Hard to maintain, easy to mess up. For a home-built 3D printer that requires a lot of maintenance, this machine surely does not make maintenance easy. If you want to change a really simple part, let's say the Y motor holder, you have to completely remove both of those threaded rods and everything that's attached to it, so basically almost everything. And then you have to put it all back together, and then you have to recalibrate your whole Y-axis and make sure that both of those smooth rods have the exact distance from each other, and so on and so forth. So it's really difficult. It's really difficult to maintain this thing. On top of that, it's like really closed up and small in places, especially when you put the electronics on top. So some screws tend to be extremely difficult to reach. So maintenance is just horrible with this machine, and it does require a lot of it. Reason number 3. Lots of wire strain. Whenever you have moving electronic parts, you get to the problem of wire strain, and you get to the problem of wires breaking. Let's look at the print bed, for example. Now, the print bed has those two pretty thick wires that connect to the heated bed, and they have those small wires that connect to your thermistor. Now, the print bed moves around a lot, but as you can see, here in the structure of the printer, there isn't really a way to attach the cables in a way that you do not have a lot of strain on them. Now, I did it like this. That's pretty good, but if I go into this position, it still puts a lot of tension on the wires, and indeed, the wires that lead to my temperature sensor are again broken. Now, obviously, there are clever and pretty simple solutions for this problem. For example, you can buy electric chains, or you can print your own electric chains, but for a problem that actually occurs quite frequently, solutions like this should really be included in the printer design. You shouldn't have to troubleshoot for hours until you find out that a wire broke, and you shouldn't have to do it 4 times in a row until you find out that it's actually a common problem. Reason number 2. 2 Z-axis motors. One of the biggest problems with this design is that you have 2 individual Z-axis motors and you have 2 individual Z-axi. Now, in the original Mendel, you had 1 Z-axis motor, and the 2 axi were connected, so that if you would turn one axi, the other one would turn in unison. Right? Now, the problem with having 2 individual ones is that you cannot just move all of this while the printer is powered off. You cannot just turn this and hope that your x-axis will move, because it will only move at one side until it won't move anymore. And you will never be able to rotate both sides exactly the same amount. That's just not possible. So that's one problem with it. The other major problem with it is that now you have two motors, but you still only use one stepper motor driver. And if you're using the standard stepper motor driver, you're using a Pololu, which is only built for 2 amperes, but two motors drain more than 2 amperes, so your Pololus can get really hot, and when they get really hot, they just turn off for a couple milliseconds. And if you're unlucky, you will miss some steps in those couple milliseconds. And the reason number one why the Prusa Mendel sucks, hanging z-axis. I don't know why the Prusa Mendel is using a hanging z-axis. Maybe it has some kind of benefits that a mechanical engineer could explain to me, but my experience with it are only negative. A hanging z-axis has a main problem that it relies on friction between your motor and your z-axis coupler to actually hold the z-axis in place. And because it's plastic, and because plastic deforms under pressure over time, it loosens up over time, and then it starts to creep downward. Your whole axis starts to creep downward. And if you're really unlucky, you're in your last minutes of a really successful print, and then your whole z-axis falls down. That happened to me once. That just sucks, because obviously, if you turn it a lot, right, and the friction isn't that much anymore because the plastic loosened up over time, it's really easy for it to just slip out of it completely. Now, just look on Thingiverse and search for Prusa z-axis coupling, and you will see that there are a lot of different ones available, and the reason that's the case is because it's such a big problem, and it's such a common problem that your z-axis will start to creep down. Even if you don't have catastrophic failure, you still have the problem that it will slowly creep down, and then your calibration won't be correct anymore. Actually, you can see it happening right here. You see that this coupling is right on top of this bearing. It wasn't like this to begin with, so what happened is that this z-axis crept down until it came to rest on top of this bearing, and now it cannot move down anymore. And that just leads to you having to recalibrate your z-axis all the time. And that's really the problem with this machine, isn't it? It was a great step towards home-built 3D printing, right? It was great, but there is so much constant maintenance. There is so much stuff that can loosen over time. There's so much stuff that can easily break. It's so much work to keep this machine running, and to keep this machine running well. I put more time into repairing this and maintaining this and making it run than actually printing. I buy or build this printer, well, to learn how to build it. Okay, I did that. But in the end, I also wanted to print 3D objects. But in the end, that's not what I'm doing. I'm constantly maintaining this thing. It's like a big ongoing project, like it's never finished. I always have to tinker with it, and I always have to repair it, and so on and so forth. But in order to get to the point where we have affordable 3D printers in every home, we need a printer that you can build yourself that can at least get to the point where it's plug and play. That you can at least get to the point where it's calibrated and where it works. And then you can just plug it in and it works. But with this machine, unfortunately, you cannot do that. My name is Max. Thanks for watching. Until next time.